Alright, hello and welcome back to my channel Buffalo School EXE. Today, I'm going to demonstrate another proof method that is highly different from any other proofs. So the first two examples or videos that I've gave to you, they're actually called direct proofs, which are proofs that are like straight to the point, or they are directly, I should say. Now today, I'm going to show you another proof technique called proof by contradiction. And the name already suggests itself, it is by supposing a contradiction, meaning the opposite of that statement, and then proving that our assumption that the opposite of that statement is wrong, and therefore the original statement is right. Alright, that's what we're going to do today. We're going to prove that the sum of at least two or more even integers is even. Assume for the sake of contradiction, this sum, I'll just write by contradiction, this sum is odd. Well, notice that it is odd, which means it could not be any like other weird numbers. Like it could be irrational somehow, or rational, or possibly pi, for example. Because notice that we're taking the sum of integers, therefore the resulting sum must be also an integer. And since we're supposing that the integer itself is not even, therefore it must be odd. So we can rewrite the sum as the definition of an odd number, which could be rewritten as 2k plus 1. And furthermore, we can suppose these even integers to be expressible as 2a1 plus 2a2 plus 2a3 plus all the way up to, say, 2an. And then we can set this equal to 2k plus 1. And since we're contradicting this, we need to show that this is not true. And the way we would do that is that we can factor out a2 out of this, and then we can rewrite this a1 all the way up to an. And this will be equal to 2k plus 1. And notice we have arrived at a contradiction pretty early, because notice that the left hand side could not be equivalent to the right hand side. Because notice that there's no way for the left hand side to be expressible as 2k plus 1. And another approach is that the left hand side is even, while the right hand side is odd. So therefore, we have arrived at a contradiction. Now the symbol of contradiction is usually written as so. So therefore, our sum must be even. And then we can put a little box or just write QED to show that the proof is well done. And this ends this short video.